Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, I will solve the first practice test paper number 1 on the chapter properties of triangles. I have already completed a few videos on the discussion of concept of properties of triangles and also solved the exercise problems from the textbook of author R.S. Aggarwal. If you have not watched those videos, I highly suggest that you watch them first and then you can try to solve this practice test paper 1. And if you are stuck at any problem, only then you can refer my this solution video. So this practice test paper 1 will have 15 MCQ questions, and roughly you should be able to complete this test paper in an hour, that is 4 minutes per question. If you are new to my channel and or not yet subscribed, I will highly request and suggest that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the practice test paper number 1. I hope you can see the practice test paper 1 on the left hand side, and on the right hand side I will solve the questions. Okay, so the first question says that the first question says that the ratio of the angles angle A, angle C, angle B in triangle ABC is 1:1:2. If the equal sides measures 10 centimeter each, then what is the measure of the longest side? If the equal sides, okay, now if the ratio of all the angles of a triangle is given, we can always find the values of the angles. So the ratio of the angles is given as 1:1:2. Now, from the concept of ratio and proportion, if you know the ratio of three quantities, and if you also know the sum of the quantities, we can easily find the individual quantities. So we know that for a triangle, the sum of the three angles is 180 degree. So we know that angle A plus angle B plus angle C is 180 degree. Now, from this fact that the sum of the angles is 180 degree and the given ratio, we can easily find from the direct formula that angle A will be 1, that is the term in the ratio corresponding to angle A, 1, by the sum of the terms in the ratio, that is 1 plus 1 plus 2. So 4, 1/4 into their sum, that is 180 degree. So this is 45 degree. Okay. Now since the ratio A and C, the terms are equal, we can always say that angle C is also equal to angle A, which is 45, and we can easily now say that angle B is equal to 180 degree minus angle A minus angle C, which is 180 degree minus 45 degree minus 45 degree. This is equal to 90 degree. So we see that the triangle is right angled and right angled at B. So the triangle should be like this. Let's say A, this is B, this is right angled at B, and we have C. It is given that, and also it is given if the equal sides measures 10 centimeter each. Now if in a right angle triangle we have two sides equals, then it has to be if the triangle is right angled at B, it has to be AB and AC are equal. It has to be AB and AC are equal. So it is given that the equal sides, this is 10 centimeter, this is 10 centimeter, and this is also 10 centimeter. Now we have to find that what is the measure of the longest side. Definitely in a right angle triangle, the longest side is the hypotenuse. This is the hypotenuse. We have to find, let's say, if this be x centimeter, we have to find x. Since we know that it is a right angle triangle at B, we know that AC square will be equal to AB square plus BC square. This is equal to twice of AB square, because AB is equal to BC. Now this is equal to 2 into 2 into what is AB? AB is 10 square. So this implies AC, that is the hypotenuse, is equal to square root of 2 into 10 square. This is 10 root 2 centimeter, because all the units are given in centimeter. So the longest side, which is the hypotenuse, is 10 root 2 centimeter, and so the answer is choice C. So while I am solving the problem, you can pause the video and take a screenshot if you think my solution will help you to strengthen your concept or understanding of the this chapter. Okay, let's solve problem number 2. Problem number 2 says a figure is given. In the figure below, BDE is a triangle in which EB is produced to F and DB is produced to G. Okay, if BDE is x degree, okay, so let's quickly draw the figure. So we have the triangle BDE. We have the triangle, this is B, this is D, this is the triangle BDE, and it is said that EB is produced to F. So means the side BE I will extend to F, and the side BD is extend to G. Remember that when a side is extended, we have an exterior angle is formed. So when the side when the side EB of the triangle BDE is produced to FV, the exterior angle, this angle is formed. And when the side BD was produced to G, this exterior angle was formed. Okay. Now we have this line, okay, G. So now we produce DB to G and EB to F. What else? If BDE is x degree, BDE, so this angle is given to be x degree. It is an unknown. Angle FGB, FGB. Sorry, it should be FBG. In the problem, it is given angle FGB, but it should be FBG. This angle is x plus 2. I think this is x plus 2. So we have angle FBG is x plus 2 degree. What else? And angle BED is x plus 7. Angle BED is x plus 7. Okay. Then the value of x is, we have to find the value of x. So these are all in degrees, x plus 7 degree, x degree, and x plus 2 degree. So we have BDE, angle BDE is x plus 7 degree. We have to find x. Okay. Now we can clearly see the angle FBG is given to be x plus 2 degree. Now angle FGB is vertically opposite to angle DBE. Angle FGB is equal to angle DBE, as they are vertically opposite. They are vertically opposite angles. So this implies that angle DBE is equal to x plus 2 degree. So now we got if you see the triangle DBE, in triangle DBE, uh, we know the sum of the angles of a triangle is equal to 180 degree. So we must have angle DBE plus angle BDE plus angle BDE, angle B, one second, angle BDE is x second, and this is not BDE but this is BED. This is BED equals to x plus 7 second, x plus 7 degree. So we have angle BED. So the three angles of the triangle DBE are angle DBE, BDE and BED, and this is equal to, should be equal to 180 degree. Now this implies that angle DBE is x plus 2 degree, angle BDE, angle BDE, where is angle BDE? BDE is x degree, and angle BED is x plus 7 degree. This is equal to 180 degree. Now we can say that from this x plus 2 plus x plus 7 equals 180. This implies, if we simplify the left hand side, we get 3x plus 9 equals 180. This implies 3x equals 180 minus 9, that is 171. So this implies x equals 171 divided by 3, that is 57. So x is 57. So the answer is choice C. The answer is choice C. Okay, let's do problem number 3. We have a figure. Problem number 3 says, in this figure, AC and BD, the segments AC and BD intersects at the point E such that BE is equal to EC. So when two sides are equal, they are indicated with two parallel lines on the middle of the each lines. So you can see the segment BE has a two two parallel lines that indicates that it is equal to some another side. So let's quickly draw the figure. We have this BC, we have this BC, we have AB, we have AB, and it is said that this figure AC and BD intersects. Okay, this is AC, so we have the triangle ABC and we have the triangle BDC. We have the triangle BDC, and BD and AC intersects at the point E. Okay, and it is said that BE is equal to EC. So we indicate this visually in diagrams by two parallel lines. This means that BE is equal to EC. Also it is given that angle ABE is 70 degree. So this is 70 degree, and angle DCE, this angle is 80 degree. This angle is 80 degree. If angle BAC is equal to, okay, so also it is given that angle BAC is equal to 3 by 2 angle CDE. Angle BEC is x degree. This is x. This is x degree. Then find x. So we have to basically find the angle BEC. Okay. Now what do we have? We have the triangle ABC, we have the triangle BDC, and the AC and BD is intersecting at the point E. Okay, and we have these two angles, 80 degree and 70 degree. Now BAC, angle BAC, BAC is this angle, and CDE. So there is a relation between BAC and CDE. Now, okay, so how BAC and 70. So, so the exterior angle. So we can see that angle BAC and 70 degree. These are interior opposite angles to the exterior angle X. Things to note that X. We note that angle BEC is equal to angle BAC plus angle ABE. Why? Because because no, let's write it this way. It is important while you solve the problems, it is important that you write the steps properly. We have angle BEC is exterior angle to opposite interior angles BAC and angle ABE. So this implies we can say that BEC is equal to BAC plus ABE, because we know that an exterior angle in a triangle, an exterior angle is equal to the sum of the two opposite interior angles. So we have this angle BEC is equal to BAC plus ABE. Now this implies that angle BEC is X and X degree, and angle BAC, let it be angle BAC, and angle ABE is given to be 70 degree. Angle ABE is given to be 70 degrees. So we have this. Okay, so let this be question 1. Also we can see that angle X is also exterior angle to the 80 degree angle and the angle EDC or CDE. So angle BEC is exterior angle to opposite interior angles CDE and angle ECD. So this implies the exterior angle, that is BEC, will be equal to the sum of the interior opposite angles, that is CDE plus angle ECD. So this implies angle BEC is X degree, CDE we can write CDE in terms of we have this relation. So from here we can say that angle CDE is equal to 2 by 3 angle BAC plus angle ECD is given to be 80 degree. Okay, now let's say this 2. Now from 1 and 2 we see, from 1 and 2 we have we get we can equate the right hand side of 1 and 2 because the left hand side of both the equation 1 and 2 is x degree. So we can say that angle BAC plus 70 degree is equal to 2 by 3 angle BAC plus 80 degree. This implies if we bring the angle BAC on the left hand side, we get angle BAC minus 2/3 angle BAC is equal to 80 degree minus 70 degree. So this implies if we simplify the left hand terms, we get angle BAC by 3 equals 10 degree. So this implies angle BAC is equal to 3 into 10 degree, that is 30 degree. So angle BAC is 30 degree. We have to find x. Now x, once we have got BAC, we know that this implies from equation 1 we get x degree equals to angle BAC plus 70 degree. Angle BAC we just found to be 30 degree plus 70 degree is equal to 100 degree. So this implies that x equals 100. So the answer is choice D. Okay. Let's do problem number 4. It is in this figure, a figure is given. In this figure, angle ABE is equal to angle ECD. Okay, let's draw the figure. First, we have this BA. Okay, so B, A, and C. So this is B, this is A, and this is C, and there is a point D which is connecting the points B and C. So, and then there is a point E. So this is D and this is E. Now this is x degree. It is given that angle ABE is equal to angle ECD. So let's say this BX, angle ABE be x degree. So we have angle ECD is also x degree. This is also x degree, and it is given that angle EBD, let's say this is y, angle EBD, so we have considered this to be x degree, and it is also given angle EBD is equal to angle ACE, this angle, so this is also y is equal to y degree. Angle BAC is 80 degree, so we have this angle 80 degree, angle BAC equals 80 degree. Angle BEC is also given to be 100 degree. So this angle BEC is given to be 100 degree. Okay. Now, Now a particular problem can be solved in various ways. You can make different types of diagrams, different types of figures by connecting some points or creating some segments. In that way, you will have different methods with different steps to solve the problem. So it is fine You just have to, whichever way is suitable for you, you think is appropriate, utilizing all your knowledge or concepts of the properties of triangles, you can follow your method. I am thinking to join the points B and C, and what if I join the points B and C, and then I will get the triangle ABC, and one angle A is 80 degree. Okay, now what, how, okay, so I have to utilize the angle 80 degree and 100 degree. So BEC is 100 degree, BEC is 100 degree, and okay, now now x, this is x degree. Oh, sorry, we cannot take x and y, because x degree is always given to be BDC. X degree is already given to BDC. So let's say this be z, this be z. So we have to consider this as z. So let's say this is z degree. So the diagram is becoming very clumsy, but so angle ABE and angle ECD Z. So we can clearly see there are three triangles: ABC, BEC, and BDC, and we have to utilize the fact that for all these three triangles we have to utilize the fact that the sum of all the angles in a triangle is 180 degree. Maybe you can extend some sides of triangle and make some exterior angles, and use the fact that an exterior angle is equal to the sum of the two interior opposite angles, but in my opinion that will make the figure little complex. Joining B and C and creating these three triangles, I think I will be able to solve it. I'm not sure, let's try. Now I need the these two angles. I need these two angles. Should I assume some variables for these two angles? It has asked find x. Okay, let's say this angle is P, and this angle is Q. Okay, so now what do we have in triangle ABC? In triangle ABC, we must have the sum of the angles will be equal to 180 degree. So we have angle A plus angle B plus angle C equals to 180 degree. Now please note that angle B is nothing but angle B, since the whole angle B we can see that has been dissected into three angles. So we have angle B is equal to Z plus Y plus P. Actually Z degree plus Y degree plus P degree. And also angle C is equal to Y degree plus Z degree plus Q degree. Okay. Now in triangle ABC we have angle A plus angle B plus angle C is equal to 180 degree. This implies angle A is 80 degree plus angle B is Z degree plus Y degree plus P degree. Angle C is Y degree plus Z degree plus Q degree equals 180 degree. Now we can without any problem ignore the degrees and say that Z plus Y plus P and Y plus Z plus Q is equal to 180 minus 80, that is 100. Now if we simplify the left hand side further, we get twice y plus z plus p plus q equals 100. Okay. Okay. BEC is given. Okay, BEC is given. Okay, fine. Let this be equation 1. We will get some few equations, and utilizing those equations we have to solve x. Now in triangle BEC, we have angle E plus angle B plus angle C is equal to 180 degree. This implies angle E, that is BEC, is given to be 100 degree. And what is B? B is Z degree plus Y degree plus P degree plus okay, let's see, C. No, sorry, actually for the triangle BEC, for the triangle BEC, we will not actually have angle B and angle C. Angle B and angle C is with respect to the triangle ABC. So for the triangle BEC, in triangle BEC, actually we will not have the angle B and C, but rather it is correct to say angle E is fine. We will have angle EBC plus angle ECB equal to 180 degree. Now this implies angle E, that is BEC, is 100 degree. And what is angle EBC? Angle EBC is Y degree plus P degree, and angle ECB is Z degree plus Q degree, is equal to 180 degree. Now this implies Y degree. Now we can ignore the degrees and say that Y plus Z plus P plus Q is equal to 180 minus 100 equals 80. Y plus Z. Now what will be X? X will be, now X will be, also we know that X will be 180 minus P minus Q, because we know that in triangle BDC, P plus X plus Q should be equal to 180 degree. Now we have to find X. Okay, we have this, fine, let this be equation 2. Now in triangle BDC, we have, if we sum the angles, we have X degree plus P degree plus Q degree equals to 180 degree. The angles of the triangle BDC are X, P and Q. This is degree. So this implies that X will be eventually 180 minus P plus Q. This will be X. So we just need to find P plus Q. We need not find individual values of P and Q. We just need P plus Q. Now from equation, if I multiply from 1 minus, if I multiply the equation 2 with 2, if I multiply the equation 2 with 2, so this I will get, we get equation 1 is same as it is, and if I subtract the equation 2 after multiplying both sides with 2, subtract that from the equation 1, we get uh, we get the left hand side becomes 2y plus z minus 2 y plus z plus, let's not write the 2 over here, let's say we have uh, 2 multiplied by p plus q. This is equal to we have multiplied the equation 2 with 2 on both sides, and whatever that equation becomes, we are subtracting that equation from equation 2. So this will be 100 minus 2 into 80. So this implies 2 y plus z minus 2 y plus z minus 2 p plus q. The right hand side becomes 100 minus 160. If we simplify both the sides, left hand side and the right hand side, we get 2 into y plus z cancels, these two terms cancels, and we have minus 2 into p plus q is equal to minus of 60. So this implies minus minus gets cancelled, so we have 2 p plus q equals 60. This implies p plus q equals 60 divided by 2, that is 30. So we got the value of p plus q. So now we know that x is equal to 180 minus p plus q. This is 180 minus 30, that is 150. But 150 is not in the equation, is not in the choice. So let's see what wrong we did. Angle ABE is equal to angle ECD. Okay, so ZZ, angle ABE equals to angle ECD equals to Z. Angle EBD is equal to angle ACE. Angle EBD is equal to angle ACE, we have considered to be Y. Angle EBD is Y, and angle ACE is Y. Okay, BAC is 80 degree, okay, and BEC is 100 degree. We have to find x. Okay, we have considered the angle DBE as P and DCB, angle DCB as Q degree. So in triangle ABC we have angle A plus angle B plus C equals to 90 degree. This means 80 degree plus angle B. Considering the triangle ABC, we know that angle B is equal to Z plus Y plus P. Okay, and angle C will be Z plus Y plus Q. Okay, so we have angle A plus angle B plus angle C equals to 180 degree. So this means 80 degree plus Z plus Y plus P plus Y plus Z plus Q is equal to 180 degree. So this means Z plus Y plus P plus Y plus Z plus Q equals 180 minus 80, that is 100. Also, after simplifying this, we get 2 into Z plus Y, because we have 2 Z terms and 2 Y terms. So we get 2 into Y plus Z plus P plus Q equals to 100. Okay, this is fine. Now angle B is in triangle BEC. We have angle BEC, that is angle E. plus angle EBC plus angle ECB equals 180 degree. Angle E is given to be BEC is given to be 100 degree. So 100 degree plus angle EBC is Y plus P, okay, Y plus P, and angle ECB is Z plus Q. So we have Z plus Q equals 180 degree. This means Y plus Z, oh sorry, okay fine, Y plus Z plus P plus Q equals 180 minus 100, that is 80. Okay, this is fine. This is fine. Equation 1 and 2 is fine. Now angle in triangle BDC we have P plus X plus Q equals 180 degree. Okay, so we have X equals 180 minus P plus Q. So if we can find P plus Q, we will find X. Now we have to, from equation 1 and 2 we have to find P plus Q. So we multiplied equation 2 by 2 on both sides, and we get and then we subtracted that from equation 1. So we get 2 into Y plus Z. Oh, sorry, I have forgot to write the term P plus Q from equation 1. So this will be actually there will be a P plus Q over here. There will be a P plus Q. So now this will be 2 into Y plus Z will cancel out, and we will have actually we will have this 2 will not be there. We will have minus P plus Q, minus P plus Q. This we will have, okay fine, minus P plus Q. This will not be 2, and so P plus Q is equal to 60 degree. P plus Q is coming to be 60 degree. 60 degree. Hence X will be 180 minus 60, that is 120. That is 120. So X is 120. So the answer is choice D. So the answer is choice D. Okay. Let's do problem number. This was problem number 4. Okay, let's do problem number 5. Problem number 5 says a figure is given. In this figure, ABCD is a square. Okay, so let's quickly, ABCD is a square. Okay, it's a square, meaning all sides are equal, and we have all the corners or angles are 90 degree. Okay, so it's a square. So let's try to roughly draw the square ABCD. AB, then we have, okay, so this is roughly a square. We have A, B, C, D. It's a square. Okay, MDC is an equilateral triangle. MDC. Okay, so we have it has joined DB. The diagonal DB is joined. Diagonal DB is joined. Fine. So M is a point inside the triangle ADB. So that it is saying MDC is a equilateral triangle. MDC is an equilateral triangle. If this is so, we must have, in an equilateral triangle we know all the angles are equal, and there each angle is equal to 60 degree. So we will have this as 60 degree. Also this is 60 degree. So we have what is asked? Find X. What is X? This is X. This is X. Okay. What can we have? This is X. Now how can we get X? We can see that X is an interior. Let's try to apply the concept of exterior and interior opposite angles from okay. Now the fact that MDC is equilateral, triangle MDC is lateral, this implies that angle MCD is equal to angle DMC is equal to angle MDC is equal to 60 degree. All the angles are 60 degree. Now, this is 60 degree. This angle is 60 degree. So, if we can somehow find, let's say this angle be y degree, then and let's say this point be E, that is where MC and DB is intersecting, let that be point E. Hmm, 60 degree, 60 degree. How can we find? If we can find y, then we can find x, because x is an exterior angle to the interior opposite angle 60 degree and y degree. How to find y? Now, okay, so we have angle BEC is equal to x degree. We also know that the also we will have MED is equal to angle BEC, because they are vertically opposite angle. So this will be x degree. Angle MED is also x degree. Let this be Z. Let this be Z. The figure is looking very clumsy. Let angle MDE be equal to Z degree, and angle EDC be equal to Y degree. Okay. Now, in triangle MDE, we get, by adding the sum of the angles to be 180 degree, we get angle MDE plus the angles of the triangle MDE are MDE plus angle MED plus angle the DM MED and angle DMC, not DMC but DME, is equal to 180 degree. This implies angle MDE we have considered to be Z. So Z degree plus MED is equal to we see MED is equal to angle BEC, that is x. So x degree plus angle DME. Angle DME is given to be, angle DME is nothing but angle DMC, which is given to be 60 degree, is equal to 180 degree. This implies we can say that Z plus x is equal to 180 minus 60, that is 120. Now, we also see that in triangle DEC, angle BC is exterior to opposite interior angles to opposite interior angles, angle EDC and angle DCE. So this implies the exterior angle, that is BEC, should be equal to the sum of the interior opposite angles, that is angle EDC plus angle DCE. So what do we get from here? Angle BEC is nothing but the x degree equals angle EDC. Angle EDC we have considered to be y degree plus angle DCE. Angle DCE is nothing but DCM or DCM, MCD. Angle DCE is equal to angle MCD. So this is given to be 60 degree. Y plus 60 degree. X equals to y plus 60. Okay. Can we find y? Also see that in triangle MDC, it is an equilateral triangle. So angle MDC is dissected into angle Z and Y. So this is angle MDC is angle MDE plus angle EDC DC. This is equal to, should be equal to 60 degree. This implies, what is angle MDE? Angle MDE we have considered to be Z degree. So Z degree plus angle EDC. Angle EDC we have considered to be Y. So Z degree plus Y degree is equal to 60 degree. So what do we get? What do we got? We got Z plus X equals to 120. This equation, X equals to 1 Y plus. So from this implies that X equals Y plus 60. Let this equation be 2. And this implies Z plus Y equals to 60. So from these three equations can be solved X. Z plus X okay, let's try. Yes, we can solve. Let's see now. Okay, so what we will do is we will this implies, we will not say these three yet. So from here we get Z equals 60 minus Y. Let this be 3. We got Z in terms of Y. Now from this we will not say equation 2. This we will not say equation 2. We will this implies Y is equal to X minus 60. Let this be equation 2. So now we got Z in terms of Y. We have Y in terms of X. So we will use equation 2 and 3 in equation 1. Now using 1 and, that is the results of 1 and 3, not 1 but 2 and 3 in 1 we get, that is we will substitute substitute, but before that let's say we got Z equals to 60 minus Y. Now this implies that Z is equal to, let's write a Y in terms of X. Let's substitute the value of Y In equation 3, let's substitute the value of substitute y with its value in terms of x that we got in equation 2. So this will be, we know that y equals to x minus 60. So this is equal to 120 minus x. So z equals to 120 minus x. Oh no. This is not helping. We got an identity. This will not help. If you put 120 minus x in 1, it will cancel out x. No, it's not working. What else can we do? We have to find x. Z plus x plus 60 is equal to 180 degree. We have found this. And y plus z is 60 degree. We have found this, y plus z. This is equilateral triangle. MDC is an equilateral triangle. What can we say? Y plus 60. X will be y plus 60. X will be y plus 60. Can we? Z plus 180 minus x equals z plus 60. We are getting a relation between z and x. Oh, we are not using at all the fact that it beat this ABCD is a square. Oh my god, ABCD is a square. Okay, so and is an equilateral triangle. So ABCD is a square. So what this angle will be 30. This angle will be 30. This angle will be 30. What is this angle? This angle is 30. Y plus z. Angle MCB is 30. This angle has to be 30 because the corners, all the angles of the square are 90 degree. Is it helping anywhere? ECB is 30 degree. If that is 30 degree, then okay, so we also know that this angle is 45 degree. This has to be 45 degree because the diagonal DB bisects, or diagonal DB is bisecting the angle ABC, and ABC is 180 degree, 90 degree. So this DBC is 45 degree. Oh, okay. So it was very easy. Oh, we need not consider all the y and z. What is x? Okay. No, I don't think we will require all this complex calculation. Let me delete all this. Sorry for wasting time. It was super easy actually. Just we have to use the fact that it is a square. Okay, so we have this. So we need not at all consider all these angles. Let's rub. We will not need. So ABCD is a square. This implies angle BCD is equal to 90 degree. Now triangle MDC is equilateral. We have already found that angle MDC is given to be equilateral. So we can say this implies that angle MCB will be equal to we know that angle MCB plus 60 degree has to be equal to 90 degree. That is angle MCB plus 60 degree should be equal to angle BCD. This implies angle MCB plus 60 degree is equal to BCD is 90 degree. This implies angle MCB is equal to 90 degree minus 60 degree, that is 30 degree. So we got MCB equals to 30 degree. Also in square ABCD, the diagonal bisects the angle ABC. This implies angle EBC is equal to angle ABC divided by 2, and angle ABC we know it's a corner angle of a square which is 90 degree. So angle EBC is 45 degree. Now in triangle EPC we have the sum of the angles to be 180 degree, that is angle EBC plus angle BCE and plus angle BEC should be equal to 180 degree. So this implies angle EBC is what, 45 degree. Angle BCE we have already found earlier, angle BCE or BCM or MCB. BCE is equal to MCB which is 30 degree plus angle BEC is equal 1. Angle BEC is x degree. We have to find x. So angle BEC is marked as x degree. So this is x degree is equal 180 degree. So this implies 75 degree plus x degree equals 180 degree. This implies x degree equals 180 degree minus 75 degree. This is equal 105 degree. So this implies x equals 105. So the answer is choice C. The answer is choice C. It was pretty simple. We just had to utilize the fact that MDC is an equilateral triangle, so all its angles will be 60 degree, and that ABCD is a square, so its corner angles are 90 degree, and that the diagonal DB will bisect its corner angle ADB, that is bisect into two angles 45 degree. So with this information and the fact that in triangle EBC the sum of its angles is 180 degree. Okay, let's solve question number 6. The measures of the sides of a triangle PQR are integers in centimeter. Okay, if two of its sides are 1 centimeter each, then the perimeter of triangle PQR is perimeter of the triangle PQR. So definitely we have to find the third side. Two sides are given as 1 centimeter. So let's say let side A equals 1 and B equals 1. So we have to find C. Now let in triangle PQR, if two sides of it are 1 centimeter each, so it's an isosceles triangle. Okay. Let it triangle PQR, let PQ. So let's since it's a isosceles triangle, we can always consider roughly that the triangle will look something like this. So P, Q, R, and this PQ is equal to R. These are the two equal sides. They are of 1 centimeter length. So we have to find RQ. We have to find this RQ. Okay, and it is given that the measures of the sides of a triangle PQR are integers. They are integers. Okay, so we have PQ equals PR equals 1 centimeter. Now we know that from the triangle inequality, for the triangle inequality, that the sum of two sides is always greater than the third side. Also, the difference of two sides is less than the third side. So we know that we have discussed this in the theoretical part, in the previous video, that if two sides of a triangle is given ABC, if ABC are the, let's say, if the two sides of a triangle are given as A and B, that is the length of the two sides of a triangle is given as A and B, what value can the third side have? So as a side note, if two sides of a triangle are of lengths A and B, we know that this implies length of third side, let's say that be C. We must have A minus B, that is C should be greater than the difference of the two sides A and B and less than A plus B. So if we apply this concept in this triangle PQR, we must have PQ QR, that is the length of the third side, should be less than 1 plus 1, because the length of the other two sides are 1 and 1, and we must have 1 minus 1, modulus of 1 minus 1. QR should be greater than the difference of the two sides PQ and PR, which is 0, and less than the sum of the two sides PQ and PR, which is 1 plus 1, 2. So we must have 0 less than QR less than 2. Now since the sides of the triangles are having the measures of the sides of the triangles, it is given to be integers. This implies that QR has to be equals to 1. This is the only choice, because all the sides length of the measures of the lengths of the sides are integers, and between 0 and 2 there is only one integer, 1. So the other side is 1. This implies perimeter. This implies perimeter of triangle PQR is equal to 1 plus 1 The sum of all the sides plus 1, this is 3. So the correct choice is choice A. Okay, let's do problem number 7. A figure is given. In this figure, in triangle ABD, let's draw the figure first. We have this BX is a line. Okay, so this is X, this is B. What else? We have somewhere A, we have BD, and AD is joined. Fine. So we have this triangle ABD. What else? We have this C somewhere, C, and AC is joined. So we have this triangle ADC. And what else? This is given to be X degree, this is given to be 45 degree. This angle is given to be Y degree, this is 30 degree, and this is some angle, and this is 60 degree. Okay, in this figure, angle in triangle ABD, B is 60 degree. Okay, angle A is 30 degree. Okay, side AB is produced to X, so that CAX, this angle Y angle, that is CAX is Y degree. Fine. Now triangle ADC, in triangle ADC, it is given that angle C is 45 degree, angle D is X degree. Then find X plus Y. We have to find X plus Y. Okay, we have to find X plus Y. Now in triangle, let's say, what will be this angle? Will it help if we find this angle? Yes, it will help. And what about, okay, so let this be Z. So if we let the angle in triangle ABD, let angle BDA equals to Z degree. Now this implies that we must have, in triangle ABD, the sum of the angles must be 180 degree. So we will have 30 degree plus 60 degree plus Z degree equals to 180 degree. So this implies Z degree is equal to 180 degree minus 90 degree, that is 90 degree. This implies okay, Z degree is, so Z is 90. Fine. Now so BA is produced to X. So BA is produced to X. We have to use this. We have to use this fact because it will create an exterior angle DAX. Okay. We have found Z. Okay. Now BA is produced to X. This implies angle DAX is equal to, this is the exterior angle. Once the side BA is produced to X, we get the exterior angle DAX. So it should be equal to the sum of its two opposite interior angles, and the two opposite interior angles are DBA plus angle BDA. So DBA, so DBA is 60 degree, and Z and BDA is Z, and Z we found to be 90 degree. So this is 150 degree. So this implies that DAX is 150 degree. Now what is DAX? DAX is angle DAB CAC plus angle CAX is equal to 150 degree. Now what is DAC? DAC. Okay, so angle DAC, we need to find angle DAC. Angle CAX is given to be no, angle CAX is not given. Angle CAX is not given. Okay, so let's angle CAX is actually Y. So we have this. We have to find X plus Y. We have to find X plus Y. DAC. How the angle DAX? Okay, angle DAX is equal to 60 plus 90. Angle DAX is equal to how come angle DAX? Oh, okay. So angle Z is 90 degree. Fine, 90. So angle DAX is exterior angle, which is equal to 60 plus 90. That is 150. Fine. Now angle DAX is equal to angle DAC plus CAX. So we have angle DAC plus angle Y, Y degree equals to 150. Also, let's DAC. We do not know Y. Okay, so let this be equation 1. Also in triangle ADC, we have the sum of all the angles to be 180 degree. In triangle ABC we have angle DAC plus angle ADC plus angle DCA equals 180 degree. So this implies angle DAC, angle ADC is X degree, angle DCA is 45 degree, is equal to 180 degree. So this implies we do not know DAC. This implies angle DAC plus X degree equals 180 degree minus 45 degree, that is 135 degree. So this be equation 2. From 1 and 2 we will not get X plus Y. We have to find X plus Y. So we need DAC. How do we know DAC? Okay, so one more equation is that the angle DAC and 30 degree and the angle Y is forming on the same side of the line BX. So their addition should be equal to 180 degree. So we also have, since the BA is produced to X, so BX is a line, and we are having the angles 30 degree, that is angle BAD, the angle Y and the angle DAC to be on the same side of the line BX at the point A. So their sum should be equal to 180 degree. So we must have 30 degree plus angle DAC plus Y degree is equal to 180 degree. Now this implies angle DAC plus Y degree is equal to 180 degree minus 30 degree. This is equal to 150 degree. Is it helping anyway? Oh, we already found this. We already got this equation earlier. The equation 1 is already the same thing. So this is not helping. this is not, this is, this we already found. So we have two equation, DAC plus y equals to 150 and DAC plus x equals to 135. If we add this to equation, we will get on the left hand side x plus y plus 2 DAC equals to something 285. But to find x plus y, we need DAC. We need DAC. How can we find DAC? We are getting Z, we know Z. What else can we know? This is 45. This is 45. So x plus DAC will be x plus DAC is 135. Fine. In triangle ADC, C is 45 and D is x degree. Okay. Now I am not sure from the figure where whether BC is a straight line or not. I mean D is a BDC is are collinear points or not. If BDC are collinear points, then definitely we can find x, because in that case Z and x will form a linear pair. Z and x will form a linear pair. We can say that Z will be 180 minus x. X will be 180 minus Z, and Z we already know. Z is 90 degree. Wait a minute. Z is 90 degree. Really? Z is 90 degree. If Z is 90 degree, okay. So AD is perpendicular to BD. If Z is 90 degree, then AD is perpendicular to BD. Even then, we cannot say for sure that BDC are collinear points. So if somehow we know that BDC are collinear points, that is they lie on the same point, same line, then I can consider that Z and X are linear pair of angles, and from that I can find X. And if I find X, I will also know angle DAC. It is asking then find Z plus X plus Y. X plus Y. DAC. X plus Y. X plus Y. Now 45. Angle C is 45. No, I am stuck here for this problem. I will move on to the next problem. I will come to this problem later on. Let's do question number 8. The sides of a triangle have lengths in centimeter 10, 6.5 and x, where x is a whole number. The minimum value of x is. Okay, so we know that if the length of two sides are given, then we know that if ABC are three sides of a triangle, we have mod A minus B, that is the difference, absolute value of the difference of A and B. I mean ABC are the lengths of the three sides of a triangle. Then we will have the third side should be greater than the difference of the sides A and B and less than the sum of the sides of length A and B. We must have this, and for this problem let A equals 10, B equals 10, B equals 6.5. B equals 6.5. So we must have and let C equals X. So this implies we must have mod A is 10, 6.5 less than X less than A plus B, that is 16.5. So this implies modulus of 10 minus 6.5 is 10 minus 6.5 is 3.5. So this is 3.5 less than X less than 16.5. So the value of X can lie between 3.5 and 16.5, and the value of X is also a whole number. Then the minimum value of X is obviously 4. The minimum value of X, we can see that it is given that X is a whole number, that is it will be 0, 1, 2, 3, 4. 0 cannot be the side, the length of the side of any triangle cannot be 0, so it can be 1, 2, 3, 4 like this. Now we have already found that X is greater than 3.5, so the next whole number is 4. So we get that X is equal to 4. So the answer is choice D. Okay, let's see question number 9. Question number 9. In this figure, in triangle PQS, in triangle, okay, let's what is given? We have this QR. Okay, we have this PQ, we have PR, so this is R, and we have PS. It is said that in this figure, in triangle PQS, okay, so this is an external angle, it is given to be 110 degree. In triangle PQS, PQ is equal to PS. This means these two sides are equal, and these are indicated by two parallel lines on the two equal sides. Okay, this means that this angle will be equal to this angle. We know that in a triangle, if two sides are equal, in an isosceles triangle, the angle opposite to the equal sides are also equal. So let's say this be y degree, these angles be y degree. Now this is x, we have to find x, and this angle is given to be 25. This angle is given to be 25. Okay, what else is given? PQ is PS, and angle R is 25 degree. Angle P is x. Angle P is x degree. Angle P in the triangle PSR is x degree. Find the value of x. Okay. By angle P, it means the angle P in the triangle PSR is x degree. Okay. Fine. Now we see that we have to find x. To find x, what do we need? We need y. No. Do we need y? We have to find x. Okay, we have to utilize the fact that 110 degree is the 110 degree is an external angle, exterior angle to opposite interior angles. Let this be z. Let this be z. So, z plus y will be 110. Oh, we can easily find y. Now, see what will be y in so angle. Let this be if we extend this, let this be t. So angle PQT plus angle PQR should be equal to 180 degree, as they are linear pair of angles. The angle PQT, which is given to be 110 degree, plus the angle PQR, they lie on the same side of the line TR, at the point, same point Q. So their sum should be equal to 100 degree, 180 degree. So this implies PQT is given to be 110 degree plus PQR. PQR is nothing but we have marked as y degree equals to 180 degree. So this implies y degree is equal to 180 degree minus 110 degree. This is 70 degree. So y is 70 degree. Okay. Now also for triangle PQS, angle PQT is exterior to is exterior to opposite, what is this, is exterior to opposite interior angles, interior angles QPS and angle PSQ. So this implies that the exterior angle PQT should be equal to the sum of the two opposite interior angles, that is QPS plus angle PSQ. Now this implies that PQT is 110 degree, it is given, and angle QPS we have considered to be Z degree, and angle PSQ is Y degree. So this implies Y we have already found 110 equals Z plus Y we have already found to be 70. So this implies Z equals 110 minus 70, this is 40. So Z is 40. If Z is 40, we have to find X. If Z is 40, okay. So Z is 40. Now in triangle PQR, the sum of the angles in this triangle PQR, angle we can say Q plus angle P plus angle R will be equal to 180 degree. So this implies angle Q is Y degree, angle P is Z degree plus X degree, and angle R is given to be 25 degree. This is equal to 180 degree. Now this implies Y we know as 70 degree, Z we know is 40 degree plus X degree plus 25 degree is equal to 180 degree. This implies 70 plus 40 is 110, and so 135 degree plus X degree is equal to 180 degree. This implies X degree is equal to 180 degree minus 135 degree. This is equal to 45 degree. So it has asked to find X. So this implies X is equal to 45. So the correct choice is the answer is choice B. Okay, let's do problem number 10. Problem number 10 says lengths of sides of a triangle are 3 centimeter, 4 centimeter and 5 centimeter. The triangle is, it is asking about what type of triangle it is: obtuse angled, acute angled, right angled, isosceles right angled. Now it is talking in terms of angle. It is talking in terms of angle. Now whether it is right angled, we can, let's check if it's a right angle or not. If three sides, if the length of the sides of a triangle are given, and we need to check whether it's a right angle or not. We have to first figure out which is the longest side, because we know that in a right angle triangle the longest side is the hypotenuse. So if let's say uh, in we know that in triangle ABC, right angled at say A, we have, we know that in triangle ABC, now okay, I think this is not necessary to write. We know that to check whether a triangle is right angled or not, if the three sides, length of the three sides are given, we obviously, if it's a right angle triangle, obviously the side having the maximum length should be the hypotenuse, and its square should be equal to the sum of the squares of the other two sides. So let's see. So check if triangle is right angled. To check, we need to check, we see 5 square should be equal to 3 square plus 4 square. This implies 25 is equal to 9 plus 16, that is equal to 9 plus 16 is 25. So it is true. So the triangle is right angled, because we see that the right angled with the hypotenuse, the length of the hypotenuse will be 5 and the length of the other two sides will be 3 and 4. So we get 5 square equals to 3 square plus 4 square. Now, so definitely it's right angled. So the choice is answer. The answer is choice C. Okay. Let's do problem number 11. Which of the following statements is not correct? Which of the following statements is not correct? A, what is A given? The sum of any two sides of a triangle is greater than the third side. This is true. This is true. This is always true. We know that from the triangle inequality, the sum of the lengths of two sides is always greater than the length of the third side. What is B saying? A triangle can have all its angles acute. A triangle can have all its angles acute. This is also correct, because we know that there is a type of angle known as acute angled triangle, where all the three angles of the triangle are acute. So for example, you can consider an angle, let's say they are triangle, let's say what can a triangle can have all its angles acute. 80 okay, let's I'm not currently, I cannot figure out an example where all the angles are acute and their sum is 180 degree. Surely such kind of a triangle exists, because we have a type of triangle known as acute angle triangle, where all the angles of the triangle are acute. So this is true. So B is true. C, a right angled triangle cannot be equilateral. A right angled triangle cannot be equilateral. This is also true, because we know that in an equilateral triangle, if a triangle is equilateral, all its angles are equal and all those angles are equal to 60 degree. But so if so a right angle triangle has one angle 90 degree. So a right angle triangle cannot be equilateral. So this is false. What is D? Difference of any two sides of a triangle is greater than the third side. Difference of any two sides of a triangle is greater than the third side. No, this is false. This is false. Which of the statements is not correct? Okay, it is asking which of the statements is not correct. So this is false, because we know that the difference of any two sides is always less than the third side. We know that the two inequalities, from triangle inequality, we know two important things. First one is that the sum of the length of any two sides is greater than the length of the third side, and that the difference of any two sides is less than the third side. The difference of the length of any two sides is less than the length of the third side. So C and D are false. Let's do question number 12. Okay, so it is a figure. In this figure, in triangle ACB, angle A is 25 degree, angle B is 35 degree. In triangle DEC, D is 60 degree, AED is x degree. Find x. So we have to find the angle AED. Okay. Okay, so I am not drawing the figure. Please refer the figure on the left hand side. So we will have in triangle ACB we have angle A plus angle B plus angle ACB is equal to 180 degree. Now angle A is given to be 25 degree, angle B is given to be 35 degree. So we have 25 degree plus 35 degree plus angle ACB equals 180 degree. So this implies we can get angle ACB equals 180 degree minus 60 degree, that is 20 degree. Angle ACB is 20 degree. Oh, sorry, not 20 degree, 120 degree. Angle ACB is 120 degree. Okay, if angle ACB is 120 degree, angle ACB is 120 degree. This implies that angle ACD will be equal to 180 degree minus 120 degree. Oh, we could have directly said angle ACD is exterior to angle ACD is exterior to the internal opposite is exterior angle, and its two internal opposite angles are two opposite interior angles are angle CAB and angle ABC, which are 25 degree and 35 degree. Anyway, so angle ACD is, we have found in a little roundabout way, but anyway, angle ACD is 180 degree minus 120 degree. This is equal to 60 degree. This we could have found directly from the fact that angle ACD is an exterior angle and its two opposite interior angles are the 25 degree angle and the 35 degree angle. So 25 plus 35 is 60. So angle ACD is 60 degree. Okay. Now angle ACD also is angle ACD is 60 degree. This implies we know that angle ADC, angle AED, which is x, is exterior to opposite interior angles. Angle AED is exterior to opposite interior angles. Angle EDC and angle ACD. So this implies angle AED is equal to the sum of the interior opposite angles, that is angle EDC plus angle ACD. So this implies angle AD is marked as x and we have to find x. So x degree is equal to angle EDC. EDC is given to be 60 degree and angle ACD I have found to be 60 degree. So this is 120 degree. So this implies that x equals 120. So the answer is choice C. The answer is choice C. Okay. Let's do problem number 13. the lengths of two sides of an isosceles triangle are 9 centimeter and 20 centimeter. What is the perimeter of the triangle? The lengths of two sides of a triangle is given and the triangle is isosceles. It is asking the perimeter of the triangle, which means we have to find the third side also. To find the perimeter, we need the three sides, and the perimeter is of a triangle is the sum of the lengths of the three sides. So two sides are given, 9 and 20. Now, and it is also an isosceles triangle. So the third side can either be 9 or 20. To make so we know the two sides of a triangle, 9 and 20. So the third side has to be equal to either 9 or 20 centimeter. Then only it will become an isosceles triangle. So let A be 9, B be 9. That is the side opposite to angle A is 9. The angle opposite to side, the side opposite to the length of the side. The length of the side opposite to angle A, we denote it by small a. Let that be equals to 9, and the length of the side opposite to angle B in a triangle ABC, we denote it by small b. So let B be 20, 20. Now, if triangle ABC is isosceles, it is given that this is isosceles triangle. This implies C equals 9 or C equals 20. We must have this. The third side has to be either 9 or it has to be 20. Now, if C equals 9, we can see that A plus C is less than B. A plus C, we see that A plus C is equal to 9 plus 9, that is 18, which is less than 20. This implies that A plus C is less than B, which is not possible. In a triangle, as per triangle inequality, we know that the sum of the length of any two sides is greater than the length of the third side. So this implies this is not possible. So this implies C equals 20. So this implies perimeter is equal to A plus B plus C, which is 9 plus 20 plus 20, that is 49. So the answer is choice B. Okay, let's do problem number 14. Problem number 14, a diagram is given in this figure in triangle PQS. No, it should be RQS. It should be RQS because P is not forming any triangle. P is not part of any triangle. So it is in this figure in triangle. It should be in triangle RQS. R angle is 60 degree, Q is X degree, and S is Y degree. Okay. QS is produced to point P. Okay, and it is creating the external angle Z degree. Angle PQR, that is the exterior angle that is formed when QS is produced to P, is marked as Z degree. If Y is equals to 5x, then find Z. Now, how can we find Z? We can find Z if we know Y, because the Z is exterior angle and the two interior opposite angles are angle R and angle S. Now, in triangle RQS, we have angle R plus angle Q plus angle S equals 180 degree. So this implies angle R is 60 degree, Angle Q is marked as x degree, angle S is marked as y degree. Now it is given also that y equals to 5x. So we can say y equals to 5x. So 5x degree equals 180 degree. This implies we can ignore the degree and say 60 plus 6x equals 180. This implies 6x equals 180 minus 60 equals 120. This implies x equals 120 by 6, that is 20. So x is 20. It has asked find z. X is 20. Now this implies that y is equal to 5x, that is 5 into 20, 100. Now we know that z degree is equal to 60 degree plus y degree, because r and the z degree is an exterior angle, and its two interior opposite angles are angle r and angle s, which are 60 degree and y degree. So this is 60 degree and y we have found to be 100 degree. This is equal to 160 degree. It has asked to find z. So z degree is equals to 160 degree. This implies z equals to 160. So the answer is choice C. Okay, let's do problem number 15. If length of two sides of a triangle are 6 centimeter and 10 centimeter, then the length of the third side can be. Okay, so let we know that let A equals 6. It will be actually 6 centimeter. I'm ignoring the centimeter. I hope it's understood. And let's say B is 10. We know that from the triangle inequality, we know that the difference of any two sides is less than the third side. I mean the length of difference of the length of any two sides is less than the length of the third side. That is, we know that A mod of A minus B. Why I am using mod? Because we do not know. Oh, for this we can obviously know that B is a greater side, B is a longer side. So we can say that in this case B minus A, we know that the third side, if the length of the third side is C, we should have, as per triangle inequality, C should be greater than B minus A and less than A plus B. So this implies that B minus A is 10 minus 6 less than C less than 10 plus 6. So this implies that we must have 4, C is greater than 4 and less than 16. So now we have to check which value among the choices we can have for C. We know that C will be greater than 4. So obviously, as per in the choice, the only choice we can have is choice D, that is 6 centimeter. So this is D. Okay, so one question I couldn't solve, which was that? This one? Yeah, I think 7. Question 7, I couldn't solve it. Let's try to give another try to this. Okay, so we got dAx is, we have to find x plus y. We have to find x plus y. X plus y. Now we know that y equals x plus 45. Have we used this fact? Did we use this fact? No. See, in triangle ADC, we can, oh no, sorry. BA is produced to X. BA is produced to X. Hmm. Uh, it is asking Y plus X. This Y plus X. So we know Z. We can find Z, and from Z, what can we get? We know Z. We are not sure whether the BDC are collinear, the points BDC are collinear or not. We are not sure whether BC is a straight line or not. If BC is a straight line or not. We have two triangles, and there is an exterior angle formed, which is DAX. 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 What else is given? CAX is given. CAX is given y degree. This is 45. Now Z we found to be 90 degree. Now if Z is 90 degree, we have found Z to be 90 degree. So if that is the case, then if we can redraw the figure, let's try to redraw the figure. So Z is 90 degree. So AD will be perpendicular. This is perpendicular. So we have something like this. This is B, this is A, and A has been produced to X. Now, for the triangle ADC, in triangle side, okay, CAX is Y. Now, how the triangle ADC is formed? 45 degree is given. Angle C is 45. Angle C is 45. Now, from the fact that AD is perpendicular to BD and the angle ACD is 45 degree, can we say that BDC are collinear? This is 30 degree. So this plus this should be 150. This plus this should be 150. And 150. This is 150 already. This is 45 degree. So this plus this should be 135. X plus now we have no idea. 45. Okay, so this is AC. So this is X and this is Y. We don't know this angle. Let this be Z. No, Z we have already assumed, which we have found to be 90. Let this be P. This is P. We will get X plus P. 45. There are only two triangles formed, and so if this is angle P, then we will have P plus X equals 180 minus 45, that is equal 135. P plus X, 135. And also we know that so this we are considering as P, this. Also we know that P plus Y angle will be an exterior angle. When BA is produced to X, we are having the exterior angle whose value is P plus Y, and this will be equal to the sum of the two opposite interior angles, which are 60 and 90. This is 150. So we must have P plus Y 150. We need X plus Y. How do we find P? We need P. Now if it is 90 degree, 60 30, Y plus P is 150 degree. Okay. What else can we have? Y. We need X plus Y. We have found Z 90. So we have only two triangles, ABD and ADC, and the exterior angle Y. Not exterior angle, Y is not the exterior angle. Exterior angle is Y plus P, that is formed when BA is produced to X. Y plus P. Y plus P is 150 degree. What other information can we have? No other information is given. B is 60, A is 30, side AB is produced to X, CAX is Y degree. CAX is Y degree, okay. In angle ADC, triangle ADC, C is 45 degree, D is X degree, then find X plus Y. No, sorry, I'm not able to solve it with the given information. I'm not able to solve until and unless BDC, the point BDC somehow becomes collinear, that is they lie on the same straight line, then we can find X. From the value of Z, because Z and X will be linear pair of angles. We don't know P, we don't know X. P plus X we will know 135, and if we add, we will need P. If we add P plus X and P plus Y, we will get 2P plus X plus Y equals to something, some value, but we will need the value of P. How can we get P? The angle DAC is not given. uh, DAC. Z. No, I will check this problem. If even though the problem from where I took the reference source from where uh, I obtained this problem in the figure, it was looking that the points B, D, C are collinear. It was looking from the figure, but just by looking at the figure, you can't assume something. You have to be very sure regarding based on what data information has been given. So whatever data has been given, this does not necessarily say that the points BDC are collinear. That is, BC need to be a straight line. Anyway, so I couldn't solve problem number 7. Sorry for this. So this brings to an end to so in solving the practice test paper number 1. I hope this video was beneficial to you. I will attach the a link of the PDF of this test paper in the description below. If this video was beneficial, then please like it, share it with your friends, and if you are not yet subscribed, then please do subscribe me, and it will support me and to grow my channel, and it will also motivate me to come up with this kind of videos on regular basis. So thanks for watching, and tomorrow I will prepare the next test paper, practice test paper number 2. So please stay tuned for tomorrow's video for the practice test paper number 2. So thanks for watching, and until the next video, take care and bye.